Stan Gibilisco here with episode J7, or number 7, in the complex number tutorial. What I'd like to do here is show you how to multiply complex numbers by one another. It's not difficult in conceptual terms, but sometimes it can get quite messy. Consider this general problem. Sorry about that. A plus JB times C plus JD. You would think by now I would know my ABCs, but I guess not. Not always. Suppose that we have two complex numbers like this. Now remember, A and C are real numbers. B and D are also real numbers. And J equals the positive square root of -1. Let's just work this out in general, like we're doing algebra. These are binomials. You remember how to multiply binomials in algebra. You multiply A times C, then you add to that the first term here and the second term there, which would be AJD. Then you multiply this by this, plus JBC, and then you multiply this by this, and add it, JBJD. Well, let's simplify this. We can't simplify AC any further. AJD, we can call that JAD. JBC, we can leave alone. JBJD is equal to, let's think about this for a minute. It's equal to J times J times B times D. Remember, the commutative law of multiplication allows us to rearrange a product any way we want. We can put the quantities in any order that we want. JJBD, well, remember what J times J is. That's just -1. So what we end up with here is plus -1 times BD, which is just the equivalent of subtracting BD. Well, we're getting there. We want to get this product into the standard complex number form, which is a real number plus J times another real number. Let's call them R1 and R2. We want to get it into that form. Well, let's take AC minus BD. Or AC plus a negative BD. Then we can move the negative BD over here. Let's put parentheses around that. Now that's going to be a real number because A, C, B, and D are all real numbers. What we're left over with now is JAD plus JBC. Well, we can pull the J out of this. Remember our distributive law. That is the same thing as saying J times AD plus BC. That's a real number because when we multiply two real numbers, we get real numbers, and when we add those two real numbers, we get another real number. So this is in the form that we need. So, you get rid of these intermediate steps like this, and we can say that when we multiply these two complex numbers together, we get that. That is the general form. Now let's take a specific, simple example. Let's multiply J5 times 3 plus J4. Well, that's easy enough. We just multiply J times 5 times 3, and then we add to that this times that, which is J times J times 5 times 4 equals J15 plus J squared 20. Well, J squared is a minus 1. So actually we're subtracting 20. Well, that's in the wrong order. We should switch it around and say that this product is minus 20 plus J15. All you got to do is just very carefully grind through the multiplication of one binomial by another binomial, paying very careful attention to two things. The signs, the minus times a minus, like a minus 1 times a minus 3 equals positive 3. Remember how the signs go. Remember that adding a negative is the same thing as subtracting. And you can always remember that J squared equals minus 1. And if you end up with a minus J squared, you're going to get minus 1. You just be very, very careful about your signs and about your processes. Let's take another simple example. 6 times 2 minus J7. Well, that's even easier than the previous one. 6 times 2 minus J, or minus 6 times J times 7 equals 12 minus, and we can call that J42. 6 times 7 equals 42. Now let's do a little bit tougher one. 2 minus J3 times minus 7 plus J4. Okay, 2 times a minus 7 is a minus 14, plus 2 times J4 is J8, that's J times 2 times 4, minus J3 times a minus 7, now that gets a little tricky, minus J3, okay, that's J times a minus 3 times a minus 7, and that is the same thing as J21. This is, when we subtract J3, that's like adding J times minus 3, so we get J times minus 3 times minus 7 equals J times 21, and finally J times a minus 3 times J times 4, which equals minus 14 plus, now J8 plus J21, remember our distributive law, that's J29. Now we get this one, J squared, J times minus 3 times minus 4, or times 4, which is a minus 12, which equals minus 14 plus j29, and then this is plus a minus 1 times a minus 12, which is just plus 12. Finally, we add the 12 and the 14, or 12 and the minus 14, sorry about that, and get a minus 2 plus j29. That is this product. You would never imagine that that you would get a 29 out of this. I mean, it just doesn't seem intuitive that would happen, but that's what happens. That is our final answer here. So that is how complex number multiplication works. Now, I would like to get into complex number division, but that gets exceedingly messy. That is covered in pre-calculus books, and there are formulas that are derived for that purpose. But when you have a quantity like this, the only thing I can tell you is either know the formula is derived in a pre-calculus textbook, or be very, very afraid. Stan Gibilisco, signing off.